Hi guys, I have absolutely no idea what he just spoke, but I hope it was good. Okay, so I'm Mohit. I'm managing partner and founder of a venture capital firm called Authority Capital, where we invest in blockchain startups, and that has given us a lot of leverage and leeway of understanding blockchain. So can I have that clicker thing? Acha, it's already there. Okay. Okay, so I had a word with Nur Sultan, and I wanted to understand the kind of audience it'll be over here. So I just want to understand, like, how many of you are from the tech world? Anything to do with technology? One guy? Wow. Technology world. How many of us work with technology? Okay, quite a few. Cool. How many of us are from, say, government official, government side? Anyone over here? No? And how many of us are building their own companies? Okay, a couple. Okay, cool. Okay, so the purpose of this, you are building your own company? You're building your own company? Okay, so I hope I'll try to be very slow, and I hope that all of you will be able to understand me. The purpose of this entire talk is to make you understand what blockchain is in a very simple, plain English, so that by the end of it, you are able to understand what this can do, what this cannot do, and you have a mental model ready to, because these days, if you really look it out in the world, everybody is trying to throw blockchain at any problem, and they're trying to raise millions of dollars. But in reality, most of these things will not work. So we'll just try to understand what it can do, what it is in very plain, simple English. All right, everybody's with me? Okay, cool. Okay, before I start, let's start with the problem first. Why do we even need something like this, such complicated thing, so that we have to sit over here and then start talking about it? So imagine a scenario where my friend, sir, what's your name? Muhammad. So suppose Muhammad goes out to a different country and he's like on a vacation over there. But one day he calls me back and says, Mohit, I have run out of money. Can you send me some money? I say, sure. I'll send you some money. So I hang up his phone. I dial. Sorry? Okay. I hang up his phone. I call my bank manager and I say to my bank manager this thing. Hey, can you transfer, say, $10,000 from my account to Muhammad's account? And my bank manager says, sure, I'll do it. Now, now what he does is he goes back and opens up a register. So we are not talking about computers just for the sake of simplicity. So maybe he opens up a notebook or a register and makes a single line entry, something like this, where it says from Mohit to Muhammad goes $10,000. And as soon as he writes this entry, he calls me back and says, Mohit, I have transferred the money. I said, sure. I call Muhammad back and ask Muhammad, have you received the money? He says, sure. And he tells me how much he loves me. So, what just happened? The transfer of money from my account to his account when he is like on a vacation in a different country, all it required was just one line entry in a notebook of my bank manager. So my bank manager didn't take out money from my account, deposited it in his account. He didn't take out money, went back to the country that he was in and gave him the money. All he did was just make one line entry into the notebook that he contained. So now here is the situation where a couple of things could have happened. Number one, what if when I called my bank manager, he would have misheard something? For example, instead of Mohammed, he would have heard a different name. That is one possibility. Another thing, what if he heard it right, but while making this entry, he made a mistake, a genuine mistake? Or third thing, what if my bank manager was his best friend and he tried to just give him a favor and genuinely try to make a dishonest attempt to transfer more money than I intended to. So these are the three possibilities that could have happened. Two are mistakes, one is dishonesty. These things could have happened because the notebook is not in my control. The notebook is not in his control. The notebook is in somebody else's control. So these are three possibilities, again theoretical possibilities that could have happened. So ultimately, if you really look at things, almost every important thing in our life, be it our names, be it our nationality, be it our constitution, be it our laws, be it our money, all of these things are nothing but just some entries in some notebooks. That's just some entry in some registers. That's all these things are. So now the question some funny people or say wise people or say smart people started asking was, is there a way to maintain the same register, to maintain the same notebook, but without somebody else's ownership? So if I have to maintain a notebook, if Mohammed and I have to make some transactions, so is there a way to maintain the same notebook, but without requiring my bank manager or his bank manager? That was the question people started asking. And the answer to that was blockchain. So blockchain, how complicated and flamboyant it may sound, is nothing but just a method that we'll together understand today to maintain the same notebook among ourselves without somebody else. So let's understand how it works. So so here's how we'll understand. Imagine this room, and this room says whenever we want to send money among ourselves, only among ourselves, we'll do it among ourselves only. So here's how it works. So imagine 10 people in the room. Just for the sake of simplicity, imagine 10 people in the room, and each one of them says, we want to maintain this register, we want to maintain this notebook among ourselves. So here's how it works. So these 10 people, all of them are sitting together, and all of them are sitting with a piece of paper and a pen. That is the current situation. Everybody's with me? Cool. So if all of these 10 people are sitting with a piece of paper and a pen. So here's the rule number one, or say the step number one. What happens? So the step number one of blockchain is anything important that happens in this group or in this community has to be announced loudly and clearly to everybody. So for example, this. So for example, number 2 says, I want to send $10 to number 9. Now number 2 will not call his bank manager. Instead, what she'll do is, she'll loudly and clearly announce it to everybody in the room. She'll say, hello guys, I'm number 2 and I want to send $10 from my account to number 9's account. And she says it to everybody. Now what everybody does is, all of them make the similar entry, which looks like this, on their own individual pages. So everybody writes on their own pages, from number 2 to number 9 goes $10. Everybody. So nobody is like depending on anybody else's pages, everybody is writing on their own pages. But again, you would say 3 things could have happened. Somebody could have misheard it, somebody could have miswrote it, or somebody could have tried to be plain dishonest. We'll try to fix it. But the step number one is, anything important that happens in this community or in this group has to be announced loudly and clearly to everybody. And everybody can make announcements only about themselves, not about somebody else. Nobody can say, I am number 2, but number 4 is sending money to number 9. No, everybody has to say, I am number 2 or I am number 4 and I want to send this much money to somebody else. Understood? Okay, so now what happens? Now these announcements keep happening over and over. Say in next 10-15 minutes, say 20 different announcements have happened. So number 9 says I want to send some money to number 3, number 4 says I want to send some money to number 7, and this goes on until we run out of the space on the page. Now enough announcements have been made in this group so that all of our pages on which we were writing, there's no more space left. The page is filled. Now what we have to do over here, this is the part 2, or say step 2. Now what we have to do over here is, we have to take this filled page, file it away in a file folder, like just keep it away, keep it aside, bring out a new page and repeat the entire process again. So over a period of time, this pages by pages will form the same register or the notebook. But we have still not solved this one fundamental problem. What if when because everybody is writing on their own pages. So again, there's a possibility, ma'am, that somebody could have misheard it, miswrote it, or tried to be plain dishonest. So how do we fix this at this level? So now, remember the point when people have filled the pages and they're about to file the page in the file folder. Here, everybody has to seal their pages. Now, here's where the crypto part of the cryptography comes into the game. Where everybody has to seal the pages so that 2 conditions are met. Number one condition is, when people are filing away the pages, keeping the pages aside, it has to be made sure that everybody had the same contents on their pages. Everybody has to be on the same page when all of them are filing away the pages. There cannot be multiple versions of the page when the announcements were made. So this thing will fix the mishearing, miswriting and the dishonest problem, and we'll see how that is done. And second, once the page is filed, nobody can go back and make some more changes. Because once we have agreed upon something, it should not be allowed to go back and make some more changes and then say, hey, like, this is what I had. It should not happen. So how do we do it? We do it using something called hash functions technically, but for this session, we'll just understand it using this mathematical function, which I like to call magic machine. So this is a magic machine, and here's how it works. So this magic machine takes one input and spits out one output. Now here's how input and output looks like. So input is a very sensible data, say the number 4. But as soon as you pass number 4 in this magic machine, which actually is a mathematical function, it will spit out a garbage looking value, say DCBEA. It will spit out a word which will make absolutely no sense and will relate nothing, not at all, to this number 4. If you will pass, say, number 26, it will spit out another word, and this time it contains some letters and some numbers too. So this machine, what this machine does is, it takes a very sensible looking input and spits out a garbage looking word. A garbage looking word which makes absolutely no sense. But here are the properties of this machine. Number 1, when you pass in the input, you cannot predict what the output will be. This is property number 1 of this mathematical machine. So think of this as rolling a dice. You can roll a dice, but you cannot predict what the output will be. So this is one property of the machine. When you pass a number, a very sensible looking data on the left hand side, you will never get to know what the output will come. Property number 1, alright? Cool. Now the property number 2, every time you pass in the same data, every time you'll get the same output. So when you'll pass, say, number 4, you'll not know what you'll get on the right hand side. But the next time you'll pass 4, you can be very sure that you'll get the same data. Number 1, so we'll just repeat these 2 properties because these 2 properties are very important. Number 1, you cannot predict what the output will be when you pass in some data. Number 2, but if you'll pass the same data, you'll always get the same output, same garbage. Alright? Cool. Now here's how we will use this machine to seal the things. So this is a puzzle. Okay, and we'll set a ground rule first. Like, we'll set a ground rule from here onwards. So everybody among this crowd, whoever will be the most interactive, like asking questions and answering, they'll get some free cryptocurrency at the end of it. Like, I'll just pick the most interactive guy and I'll share the contact details, and I'll send some bitcoins to the guy or the girl. Okay, so here's the question for all of you. Now, you remember these 2 properties of the machine? Now here's a problem, here's a challenge, here's a mathematical challenge. Now, the magic machine is over there. Now I ask you to find an input, such that when this input is passed in the magic machine, the garbage that you get must start with 3 zeros. So it can be 000 AB, 00012, 00000. It can be anything after 3 zeros, but it must start with 3 leading zeros. How do you do it? It's not a technical question, it's a pure logical question. You know you cannot predict the output, but still there's one way, and just one way, to figure out the input such that when you will pass this input in this magic machine, you'll get 3 leading zeros on the right hand side. How do you do it? Anybody wants to take an attempt? Sure? Yes, sir?
Maybe you try to write in input something empty.
Empty? No. No. Empty would mean that every time you'll get 3 leading zeros. Yes, sir? Try all numbers? Very good. Sir, what's your name? Tim? Alright, Tim? Yes. Tim is right. So the only way to find this input is you try all numbers starting from 0. So you pass in 0, you'll not get 3 leading zeros. Throw it away. You pass in 1, no 3 leading zeros. Throw it away. 2, 3, 4, 5, 6, 7, until you get a number that starts with, so you try all the numbers until say you get to a number that gives you 3 leading zeros. So this number, in this case 72533, is the solution to this puzzle. So this is a mathematical puzzle that is used to make sure that everybody had the same contents. Now we'll see how this simple mathematical function or this simple puzzle is used. Everybody's with me till now? Cool? All right, cool. Yeah. Yeah, so if you understand what I'm saying, just give a good thumbs up. Oh, nice. Yeah, yeah, yeah. Okay. Thank you. Okay, cool. So this was now I'm just going to make this puzzle a little bit more difficult. Here's how we'll do. Now, Mohammed, it's your turn now. You got to answer this. Cool? Okay. So here's the puzzle. So the puzzle is this. Now imagine a page. Now imagine a page, just one big page, on which only there's just one number which is written, which is 20893. Just one number is written on this page, and we have to seal this page. We have to seal this page such that no changes can be made to this page at a later date. So this is the puzzle that we'll solve to seal the page. All right, Mohammed, it's your turn now. Can you please stand up? Okay. Okay, so the puzzle is this. So puzzle is this. We have to find a number that when added to 20893 and passed in the magic machine gives you a word that starts with 3 leading zeros. Mohammed, how do you do it? I just sent you $10,000. Come on. Okay, yes, of course. The problem was different, but the solution was same. You try all the numbers starting from 0. First you add 0, nothing, 1, nothing. You keep trying until you get to a number, say 21191, that when added to 20893 and pass in the magic machine will give you a word that starts with 3 leading zeros, which is 00078. So this 21191 is the solution to this puzzle, and how we'll use this solution is, imagine that page on which just one number was written, we'll just put a small slip which says 21191. So this number at the bottom is the ceiling number for this page. Is the ceiling number for this page. Now at any future date, if I'll go and try to say change this 20893 to 20894, now what will happen is, Mohammed can come and say, hey, let me check if the contents has been changed or not of this page. So he'll add both of these two numbers, which I have already changed now. So 20894, he'll add 20894 plus 21191, add these two numbers up, pass in the magic machine, and what he'll get is not 3 zeros. So he'll say, I cannot trust this page. The contents has been changed because this number is actually not the solution to the problem that I solved when I put this slip on the page. Right, so this is how we stop. This is how we stop from making changes at a future date. All right, now imagine the point. Now imagine the time when all of us were making these announcements on the pages, and we have just run out of the space on the page, right? And we were ready to file this page aside. Now at this point in time, this is the step 3 of managing this notebook. At this point in time, everybody starts solving this puzzle. Everybody with their own pages. So puzzle looks something like this. So the puzzle looks something like this, where the first input is the contents on their pages. So whatever they have heard, if they have heard it right, or if they have written it right, or if they were trying to be dishonest, whatever they were trying to do, they take their contents of their pages, then they try to find a number such that when appended to the list of all the announcements and passed in this magic machine, must give a word as the output that starts with 3 leading zeros. So everybody is trying to solve this problem. Everybody, because everybody is trying to seal their pages so that modifications cannot be done. So when everybody is trying to solve this puzzle, again the solution is same, Mohammed. Like you try all the numbers. But when somebody reaches to a number that solves this page, so he or she again makes an announcement to the group. So in this case, number 5 says, all right guys, I have done it for you. I found the number. So the ceiling number for our current page that we are all working on is 912574. He makes this announcement to everybody. Now everybody is like, oh wow, like you have done it, cool. So I'll quickly verify. So now what I'll do is, I'll take my contents of the page, of my page, I'll add your number at the bottom of it, and I'll try to pass this entire thing into the magic machine. And I'll see if I get 3 leading zeros or not. Now there are 2 things that could happen. Number 1, if I and both number 5 had been honest and have made no mistakes, this number will also give me 3 leading zeros, right? Right? Okay, cool. So this number will, so for all the honest players and people who have not made any mistakes, this number will give them 3 leading zeros. But for the rest of but for the rest of them, it will not give 3 leading zeros. All right. So this particular announcement, which was the ceiling number of this page is 912574, actually makes sure that everybody is on the same page, because everybody says, all right, number 5, I have heard your number, I have run it through my page, and it is also giving me 3 leading zeros. So which means your ceiling number also solves my problem. So you also put number 912574 on your page. I'll also put this as a ceiling number on my page, and every honest player, which hopefully is the majority of the group, puts the ceiling number on the page, files away the file folder, files away the page away in the file folder, bring out a new page, and start the whole process again. But now here's a gotcha. There's a situation that could arise. So for example, number 8 could say, guys, like I know like this number is working out for you, but somehow this number is not working out for me. What do I do? Now 3 things could have again happened. Number 8 could have misheard something, genuine mistake. Number 8 could have miswrote something, again a genuine mistake. Or number 8 tried to be dishonest into the group. Maybe he tried to take sides with somebody. So now what do we do? So number 8 is saying, like for the 9 of you, this thing is working, but for me, no. So the rest of the world says, so the rest of the 9 people says, all right, number 8, I know, we'll give you benefit of doubt. We are not going to throw you away. So now you have 2 choices actually. So number 8 has 2 choices. Choice number 1 is, you stay adamant on what you have written, and you say, I am right, everybody else is wrong. So in that case, the majority of us, the 9 people of us, will stop acknowledging your presence. We'll start ignoring you into the group. Whatever announcements you will make, we'll pretend we have not heard them. And whatever we have made announcements, we'll not pretend if you have written or not. So we'll just start ignoring you, or basically we'll throw you away. This is one. So if you don't want to play along with this group, you might as well leave. This is one situation that number 8 can do. Second situation. What number 8 has also been an option is, people have said, all right, this could be a genuine mistake, so why don't you throw away your page? Because your page is not satisfying this number, but for everybody else, this is satisfying. So why don't you just throw away your page? Just throw it away. Copy someone else's page, put this ceiling number, and file the page away in the file folder, and start playing the game all over again from the next page onwards. In either of these cases, the group that is left is always on the same page with the sealed pages, so that it cannot be changed in the future. Right? Everybody still with me? Yeah, cool. And in case you get any question, please raise your hand, and I'll be very happy to answer all of these questions, because I know sometimes it gets very complicated to understand this mathematics and the economics and the lying and the truth and the mistakes and the dishonesty part. But yeah, just raise your hands, and also like there are free bitcoins towards the end. Yes, sir. Yeah, okay, so I'm coming towards it. Yeah, you are jumping. Okay, I'm coming towards it. Okay, so this is ceiling number. Now what really happens is, pages after pages after pages after pages, this process keeps on going. And this forms the same register, same notebook that my bank manager was trying to maintain for us. But this time, among these 10 people, among ourselves, we did not require the 11th person to do it. But there's still one last thing that I would just want to mention over here. One last thing, Mohammed. And this is where your question will become relevant. Everybody went to college and schools at some point of time, right? Whenever we were given an assignment and all of us had to do it, did all of us do it? At least in India, we did not. What usually we did was, we just waited for one guy or girl to do it, and then the entire classroom would just copy from them. That's what we did in India. So now in this case, when everybody had to find a solution to the pages, why everybody was doing it? If I had been there, what I would do is, I would just stand like this, pretending to work but not working. Because I know someone else is working, and somebody will make the announcement of the ceiling number, and I can just quickly verify, right? But why everybody was working? everybody was working. Any guesses? Any guesses, Mohammed? You want to take a guess? Sorry? Uh, no, no. But see, everybody is working. So if one guy is not working, things will still work out. Yeah, okay. So everybody has to work, but why would I work? Because just think it like this. If 10 people are working, I would say one guy might make mistake, but if just I am not there, the rest 9 guys are still there. So this thinking can actually make everybody stop working. Any guesses why everybody was working? Okay, yeah, kind of right. So here's the last rule of the game. Anyone who is the first one to find a ceiling number of a page gets some free money. So everybody who makes this announcement that ceiling number of this particular page is this XYZ, he or she also gets to claim, say, new money from the system. He says, because I did some work for this entire group, so I must be rewarded. So entire group says, all right, cool, so here's your free money. So before filing the page away in the file folder, we'll make one last transaction which says, out of nowhere, say number 5 gets, say, $12 extra. I don't know what the currency is over here. I just landed this morning. So say 12 extra dollars. So this out of nowhere, some new money is created and given to number 5 that he can spend later on and send it to anybody. So this is why everybody was working. And this entire process, if you have ever came across a term called mining, this is what mining is called. Everybody is trying to find the ceiling number by deploying these large computers and making random guesses, because if their guess turns out to be right, they will be given some free money. And why this is called bit mining is because finding this number in the infinite set is as difficult as mining gold. So this is what mining is called, and this is what pages after pages after pages. Technically these pages are called blocks, and this chain of blocks that starts forming is called blockchain. So blockchain is nothing but just a set of pages, each individually sealed and filed away by the entire group among themselves, that makes the same that fixes the same purpose, that serves the same purpose as the notebook of my bank manager did. But this is what the blockchain looks like in real world. This is the ideal world, but this is the real world. Now in real world, contradictions do happen. In real world, things like this do happen, where imagine this. Suppose Muhammad announces a ceiling number and he says this is the ceiling number. But now not one, but say 5 people or say 3 people contradicts him. They say, no Muhammad, your ceiling number is not working out for me. So now what happens? The entire group of 10 people cannot just these 3 people out. So, and 3 people just say, hey, we are not going out because this other ceiling number is working for me. There can be contradictions. So what really happens is, because nobody is in control of anything, so sometimes there are like multiple versions of the notebook in the group. So in this group, Mohammed could be maintaining a notebook with a different version. Sir could be maintaining a different notebook with a different version. I could be maintaining a different notebook with different version, which I believe is my truth, which Mohammed believes is his truth, which Sir believes is his truth. But this is what it looks like. So for example, see the red chain over there? So for example, after the third page, there is a conflict between the group. And some people started maintaining this green version of the pages, and some people started maintaining this red version of the pages. And both are right. Actually, nobody is wrong. But if I'm a newcomer, what do I really see? So which one is the right version? So the rule is the longest chain is always the honest chain. Why? Because most number of people in a group are working towards it. So because more people are working, more pages are added, and that's why it has become the longest chain. So whenever you see multiple versions of a notebook or multiple versions of a blockchain in a community, you always pick the longest chain because that's the honest chain. And this, my friends, is what a blockchain is. And if you have any questions now, I'll be happy to take any questions. If I have missed something, skipped anything, if you want me to repeat anything, yeah, I'm here. Yeah, so almost, yeah. So this is what a Bitcoin blockchain looks like. The difference between multiple blockchains is in two parts. Number one, what is the data that you're writing on the blockchain? So if you're writing something about money, it becomes the Bitcoin. If you're writing something about, say, computer programs, it becomes Ethereum blockchain. If you're writing something about, say, something else, say blog posts, it becomes Steemit blockchain. So remember this, almost all the important things in our life, see, even like who owns this building, this ownership is proved only by going somewhere and finding in some register that this XYZ person owns this hotel. Like even the ownership of our major possessions are just in the databases. So yes, so the difference between blockchains is, number one, how do you seal these pages? There are multiple ways to seal the pages. This was the first one. There are multiple ways to seal the pages. And number two, what kind of data you are writing on this blockchain. These two things differentiate one blockchain from another. Yeah, sure. So if you want, you cannot. Now see, suppose you come up one morning and says, I want to make the longest chain in the group. Actually, you have to work with the group. Now you will say, whatever you guys are doing, I don't worry about you guys. Like whatever announcements you are making, I'll not pay any attention to them. I'll keep making more pages after more pages after more pages. Now understand this, you are one single person trying to find the ceiling number for all the pages. And over here, there are 100 different people trying to find the ceiling number for the for their common pages. So they'll always win. They'll always be ahead of you. So by the time you will find the ceiling number, say for 3 pages, this group would have found the ceiling number, say for next 300 pages. So you'll always be catching up. So it is not up to your discretion to make the longest chain. So the longest chain is always possible with where the majority of the people are working towards. Sorry? Not really a pool, not really a pool. Yeah, in practical terms, there are pools where you connect to this one guy because one guy is coming up with a lot of processing power, and you try to like deploy, you contribute with your small, tiny amounts of processing power, and you get rewarded proportionally. But this is not pool, this is not pool, this is like working towards the common truth. If everybody is working towards a common truth and you're trying to digress and go somewhere else, you'll be the only alone single guy who is going in a different direction. This different direction will be valuable to you, but not to anybody else. So again, like I'm not saying anything is wrong in different versions. That is his truth. He believes in it, but only he believes in it. So it doesn't matter to anybody of us. Yeah. Anything else? All right. Everybody seems like they have understood everything. Or nothing? Sorry? Yeah, sure, go ahead. I'm sure we are going to be friends after this. You no, you can put anything, but there's a limit on there are limits. But again, this limit is only for different limits for different blockchains. So you can start your own blockchain where there are no limits. You can do that. But again, you have to make sure that these announcements, basically it's like number 2 is sending money to number 9. This is a small thing. But if I say number 2 is sending a Wikipedia to number 9, so I have to send the entire Wikipedia text to him. So this is like a long transaction that has to be. So you can make your own blockchain with different sizes, but yes, the blockchain, this community has decided that this thing, that for this single purpose, say money, you don't require more than this information. Maybe a little bit more buffer, but nothing more than this. Yeah. Anything else? You both are friends together? Okay, cool. Anything else? Yeah. Okay. You definitely can input that information, but understand this, that the information must be mathematically verifiable. So suppose you claim that you have $10, I can go and check if you have $10 or not. But if you say, my family ancestor says this, how can I verify? So the information has to be verifiable independently. So I do not need, I should not, in ideal world, I should not have to go to a different party or an entity or an organization to verify this information. Because in that case, I am trusting this organization. information has to be independently verifiable, and this is where the hard part of blockchain is. Now if you'll see out in the world, people are talking about supply chain on blockchain, this thing on blockchain, this thing on blockchain. Blockchain can solve any damn thing, I agree. But why? Because blockchain is just another database. But blockchain is a database without an administrator. So in that case, in this scenario, you have to make sure that what information goes in this database has to be publicly verifiable independently. And that is where most of these projects fail. Because when they initially they're like, hey, we can put this thing on blockchain. It makes sense. It absolutely does. But now when you really try to go and put this thing on blockchain, you start asking this question. How do you make someone able to verify this information that I've just put on the blockchain? And in most cases you cannot, because most things are not mathematically verifiable. For example, his name is Muhammad. How do I even verify? I can go and talk to somebody else, but then I'm trusting somebody else. So how do you even make these things verifiable? These are the unsolved problems, both on the technology and on the economic side of things. And these are the problems that if are solved, will be a huge breakthrough in the entire technology thing. But there are still good use cases that can actually be implemented on top of blockchain. So yeah, do not try to just slap blockchain on anything. This is what I have been seeing over last 1.5 years of making investments. People are just, and there had been instances where something like this has happened. People are saying, hey, I'm building this ad network on top of blockchain, and it makes sense because everything is transparent, and all the value is given out to the users, to the community members. I say, it looks good, but how do you make this thing publicly verifiable? And the guy's like, I don't know, we'll figure it out. I said, do this one thing. Like, I like your entire thing. Throw the blockchain away, take the money. So in a lot of cases, people are using blockchain thing just to raise money. They have such good business models, but just to raise money, they're trying to use blockchain, which I believe will not make any sense when they'll try to implement it. So think of the problem. Blockchain is not the solution. I also hear this one thing, which is blockchain is a kind of solution which is trying to find a problem, which is like hilarious. But yeah, blockchain can only do limited things. This is the reality. But the limited things that it can do wonderfully. Sir, you have something? Yeah. Yeah, yeah, yeah. Okay, so the magic in this magic machine are the two things that I said earlier. So this magic machine is technically called a hash function. So hash function is a mathematical function. So the properties of this magic machine, which is two. Number one, that if you pass a sensible data, it will give you out garbage, unpredictable garbage. There is no way that if I tell you that the answer is DCBEA, there is no way, except guessing all the numbers, that you can recalculate this number, the input instantaneously. There is no way. Suppose if I tell you the two numbers added up to make 17, you cannot guess which two numbers were added to make the number 17. You have to guess all the numbers, and I'll tell you, no, this is not, no, this is not, no, this is not, this is right. So this guessing, so this machine, it makes you guess and makes you put work into it and that is what makes this sealing mechanism work. So that is the magic in this magic machine. It makes a sensible looking data into garbage unpredictably but reliably. Yeah. Yes, sir. You're welcome. Okay. Yeah, yeah, yeah. Yeah, yeah, yeah. Yes, sir. Yes. Yeah. Yes. Yeah. Yes. 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 Yeah. Absolutely. Yeah. Yes. Absolutely. So what's your name? May I know it? Abdullah? Okay. All right. Yes, this is very interesting thing because now if you give the power, the ultimate power to everybody, People will use it for all sort of things, right? So this is very interesting because, see, if you really look the current situation also, all the bad things are still happening. The bad things are still happening. Now, the argument that I hear is this is going to fuel up the bad things even more, which I believe it is also going to fuel up the good things equally more. So the proportion will still remain the same, but bad things are still happening as we speak using different mode of transactions, cash. And the one thing that really this blockchain does is it leaves a trail of the transactions that really happened. So if I send you say 3 bitcoins to shoot someone, and if you're a sniper, if I send you say X number of bitcoins to shoot someone, actually this transaction can be traced back to me and to you, and we can both go to jail. How this happens is because they'll know this was a transaction that was used to hire the sniper. They'll keep going back. Okay, this transaction came from here, this transaction came from here, this transaction came from here. Ultimately, this transaction will come from a miner, like one of these guys. One of these guys who are reachable. So the authorities will reach to this guy. They'll say, "Who did you send this money to?" He'll say, "This guy." They'll go to this guy's home. They'll knock the door, and they'll say, "Now, who did you send this money to?" They'll reach all the back to me and then to you, and they'll say, "You did something naughty." So they'll take you away. So digital thing actually leaves a trail that can actually be traced back down to you, which is why I suggest if you ever have to hire a sniper, use cash, not Bitcoin. That is number one. About regulations, I am not against regulations. So I am actually pro regulations. Now, if you really see, Estonia has come up with some regulations, more countries are coming up with some regulations, and some countries are also against these regulations. They are trying to like curb this entire thing. In that sense, I ask, when Estonia can do something like this, which was part of the Russia once, why not Kazakhstan? It is about like we are in a moment where where if you accept this new change, if you adapt this new change, the economy can be entirely different, and you can regulate it. So first level of regulations will come in the form of self-regulation. So this entire miners can make a consortium sort of thing, a rule among themselves, which says, hey, these kind of transactions will never hear, or these kind of transactions will never write on our pages, and they'll have to find a pattern of these transactions. Hey, whenever these kind of transactions happen, we'll never write it. So self regulations will actually avoid these kind of transactions to happen. That is number one step. Now, how does self regulation happen? Because these people do not understand the larger workings of the governments or the geographies or the nations. So in that case, the authorities, the governments and the nations can come up with a blueprint sort of thing, where they say, this is good what you're doing, but this is also causing some problems over here. So can we collaborate where you can like, so it is about collaboration, because if you just go against them, they'll keep doing what they're doing. If you just say, hey, you do whatever you're doing and we are with you, again, it's a bad thing. But if they can collaborate and put their problems forward, hey, these kind of things are happening, can we make sure this doesn't happen? Incentivizing self-regulation, I think, is the key over here. But ultimately, this has to be self-regulated. This is very much like internet, where anybody can create a website. Anybody can create a website. There is no limit to it. But which website is more popular, which website is better than the others, which website has more controls and everything, like bells and whistles, that is controlled by one website itself, one community by itself. And that is based on that, the rest of the public chooses to use Facebook versus Orkut. Like these networks has to be self-regulated based on what value they are adding to the entire community. Yes, sir? Okay, cool. Thank you. Anything else, or I'm not sure if we have time. Okay, we have 5 more minutes. If there's nothing, I can wrap it up early. Yes, sir? You have? Oh, please, sure. Mm-hmm. Yeah, yeah. Yeah. Yeah, yeah. Yeah, yeah. Yeah, yeah, absolutely. Very interesting, very interesting. Okay, so number one, this computation power was used because computation power is scarce, is rare, right? Now, people actually have faced this problem. So I'll just break this entire answer into two things. Number one, the electricity consumption that these computers are doing right now is around 8% of what these data centers are still doing. But those are like green. They run entirely on the renewable source of energies. But still it's just about 8 to 9% of the entire data centers of Apple and Google and Facebook combined. Now, we have to replace, now there are solutions again. All we have to find is something which is as rare as computation power. Now how do we do it? So there's another method. So this method of reaching to the consensus that everybody had the same page is called proof of work, where the ceiling number was a proof that some work was done, right? Can there be other sort of proofs that make sure everybody had the same contents on the pages? Absolutely, there are multiple ways. So another such popular method, which is not as harsh on the environment, is called proof of stake, where people say, hey, this is my version of the page, and I'm willing to bet, say $10,000, that this is the right page. And if everybody bets on the same version of the page, everybody gets their money back. But if one guy who has made a mistake or tried to be dishonest, if he bets $10,000, his money will be just taken away. So now this is another incentivization, where it is not driven by technology but by economics, where a dishonest person will never bet his money on something that he knows or she knows is dishonest, right? So that claim will never happen, and all the honest people will start, again, here the scarce resources, the money that they're putting. So either you put computer power or you put your money that you own. But this is another thing where you stake something, you prove that you are staking something with the money that you put on the table, and if everybody agrees that, hey, this page is, our pages is also common, then everybody gets their money back. But in case you turn out to be the bad guy in the system, your money will be taken. And this is incentive, this is actually a punishment. So in the earlier version, you were rewarded for something, here you are punished for doing bad, right? So there are multiple ways people are actually working on it, and I believe, like in next few years, you will see this thing actually gone and a different version of it working on, which is more green. All right? Yeah. Anything else, or should we just finish it up here? Sorry, sir. Can you just repeat your question, please? Why are governments afraid of blockchain? Okay, this is very simple. This is very simple. We are afraid of what we do not understand. It's as simple as that. Now, what governments are afraid of? This is going to take away all our power, and people are doing their own things. But again, as I mentioned in my earlier answer, if they can just come up and just say, start collaborating, it's not a fearful thing to happen. There are so many nations now which is saying, come over here, build something on the blockchain. Now here, see, economics, okay. So governments are not just competing with this blockchain thing. Governments are also competing with other governments. You have to understand this. Now there's an incentive for adopting blockchain and inviting all the good talent and money from all over the world into their small nations, because this activity can change the economic things on the global scale. So governments sometimes are afraid. Why? Because they're afraid the power will be taken away from them. Number two, but on the other side, governments are also accepting. They're saying, we had been a tiny little country in the world for so long. And now when these people, these large countries who are afraid, we don't have anything to lose, we're a small country. Can we invite all of these in smart brains, more money into our economy, and make it a superpower on a global scale? So these are two scales on which governments are acting. But ultimately, governments are for the people, right? So ultimately, it has to be what people want. So if the entire nation starts working towards something, government becomes just one guy, say the number 8, where whatever government will say, they'll not pay any heed. But they have the absolute power, like the power of the force and everything. So ultimately, the thing will be, either people will start flooding towards the countries which are more accepting towards blockchain and cryptos, which again is a bad thing for in a nation to happen, because when all the smart brains are gone from a nation, the nation doesn't survive. So government has to like balance it out very carefully, and they have to like make sure that their economies are stable, yet the brain drain is not happening, yet the smart people are still staying and building things on blockchain in their own countries. So it's kind of an understatement to say they are afraid. They're not afraid. They're thinking how to like navigate this entire thing. Okay, all right.